So the summit of Kilauea Volcano has been subsiding since early May, caused by high rates of magma withdrawal towards the volcano's east rift zone. Withdrawal of magma from the summit magma reservoir has caused the summit of the volcano to subside by a maximum of around 5 feet to date. It also caused the summit lava lake to drop within the overlook vent, and it vanished from sight around May 10th, more than 1,000 feet below its high point at the crater floor in late April. Withdrawal of magma from the overlook vent destabilized its walls and led to a series of rock falls and collapses. Explosive activity at the summit commenced in the middle of the month, the middle of May. HVO has observed countless smaller rockfalls and explosions, as well as more than 10 larger explosions, which are associated with what we believe to be brief but rapid inflation or pressurization of the summit magma reservoir. These larger explosions have produced ash plumes, mostly above 10,000 feet, and in one case as high as 30,000 feet, although atmospheric conditions may have played a role. Ballistics have also been ejected from the vent. These are not yet well documented due to the hazard of approaching the area. The most recent large explosion we had was on May 30th, and following this event, the visible plume emanating from the bulk of the Halemaumau crater has been greatly reduced. Using satellite radar and other techniques, we've been able to document the enlargement over the overlook vent. That's the one which formerly held the lava lake. But clear views of the crater itself have not been possible. Yesterday, however, UAV, unmanned aerial vehicle flights, conducted with the permission of the National Park Service, finally revealed the geometry of the new vent. So from an area of originally about 12 acres in early May, that vent has now expanded to about 120 acres, mostly through collapses of the crater floor of Halemaumau and also through enlargement of the crater itself. The area of the collapse is now more than half of the original area of Halemaumau crater. The floor of the vent, as we saw it with the drone footage, is filled with collapsed rubble from the surrounding walls, completely burying the old lava lake conduit. We're still working to determine the depth of the crater. That's not known yet. Minor venting of gases is occurring and visible at the bottom, but the great majority of the plume, as I said, is gone. This is an important change in activity. I think it's still too soon to determine its significance. It's possible that new explosions will blast through the rubble at the bottom of the vent. These may or may not be larger than previous explosions. It is also possible that the vent could become permanently blocked, ending the explosions entirely. I also want to say that we're monitoring earthquakes at the summit. Deflation of the summit reservoir places stresses on faults in and around the caldera. These faults slip, producing earthquakes. HVO has recorded many hundreds of earthquakes at the summit, and we expect these to continue as the reservoir deflates. Previously, large explosions caused, as I said, brief pressurization of the summit reservoir, which temporarily reduced the rate of earthquakes at the summit. At this time, we're not sure if this pattern will continue. That is all I have right now.
Our next question comes from Miguel Marquez from CNN. Your line is now open.
Hello, thank you very much. Also, something Wendy said yesterday, something to the effect of 2% of the magma in Halemaumau is currently in the system or something to that effect. I'm just wondering, what is the implications of that? That there's 98% of the magma still sort of possibly could enter the system, or what does that mean? I didn't quite understand it. Thank you.
So this is Kyle Anderson at the USGS. There's been a lot of confusion about that number. I think what that means is that we think that the amount of material that has actually left the summit storage system is quite small compared to the amount that's actually there. So there may be some sense out there that we're evacuating most of the magma from the summit, and that's just not true. There's obviously a lot of uncertainty associated with these estimates, but from what we know about the volume of material stored in the summit and our estimates of the rate at which it's going to the rift zone, that is probably a small fraction, on the order of a few percent. But I emphasize there's a lot of uncertainty with that number.
Okay, so we could, I mean, this, in other words, this could be a very long event if we have 98% left to go in or whatever it is in Kilauea itself.
It may or may not be a very long event, but it won't be controlled by that 98% number. It's controlled by factors probably in the rift zone and how quickly magma is withdrawn. It's not really controlled so much, to our understanding, by how much is still remaining at the summit. You're right that if we continue to withdraw magma, we could, I'd say, should say, do that for quite some time based on the amount stored at the summit. But that number of storage at the summit is not really the controlling factor here.
Fascinating. Thank you very much.
Sure.
I'm guessing that's me. It's Tom. Kyle, you mentioned that the magma column at the summit is now blocked. Is that correct? And is that preventing ash emissions for the time being?
Yes, that's right. This is Kyle Anderson, USGS. Yes, that's right. From the UAV footage yesterday, the bottom of the vent is essentially filled with collapsed material from the walls. There are some minor gas emissions we can see from a number of places on the crater floor, and arguably a little bit of ash emission, but nothing like what we saw before. So the great majority of those emissions are currently blocked. We don't really know the implications of this long term. As I said before, this is a rather significant change, or at least two things have happened. One is following an eruption and an explosion on May 30th, this plume vanished. So that's the first thing of note. And the second is that yesterday we were finally able to get a visual on the vent, which we didn't have before from the UAVs. So putting those things together, I think we have a better understanding of what's going on, but the significance of the fact that the plume is largely vanished now from that part of the vent is unclear.
If you haven't seen the UAV footage, it's posted on the HVO website now.
Hi, this is Kevin Beacon, Star Advertiser. I just wanted to follow up on the discussion of the blockage and I don't quite know what the right terminology is, within the crater. I think at the beginning of this month there was a information released by USGS that suggested that if that column became blocked, that would increase the chances of an explosive eruption that could hurl rocks some distance. Is that sort of what you folks are projecting, or what you think might happen? And does that blockage increase the chance that pressure will build up and have that kind of an impact?
Yeah, this is Kyle Anderson, USGS. It's a great question, and I think it is certainly possible. The vent is blocked, and so it is entirely possible that a new explosion will occur, throwing the material that is currently blocking the bottom of the vent there out and creating a ballistic field, perhaps larger than what we've seen before and perhaps not. It is also possible that this is the way explosive eruptions at the summit end, and whether or not this is the event that ends it or it happens later, I think is not clear. But it may be that eventually, as enough material collapses blocking the vent, we just don't see any more explosions. So right now, we're not sure if this means we have larger explosions coming, or perhaps the end of the eruption, or maybe even something in between. This is a change from what we've observed over the last couple of weeks, and we're still trying to determine what the significance is. So I think a number of options are still on the table at this point.